regression, and I
where we have. So till now we have seen this, right? Nice. You have this AI in which comes ML, right? And for ML, you have this supervised and unsupervised division. And this supervised case, we will be looking into regression and classification. And unsupervised, we will look only at the clustering portion. Okay. This thing. So I hope regression, classification, clustering is clear. Regression is almost like your curve fitting. When you scatter plot it, it gives you the idea, right? Visually, as to what the best line of fit would look like. So regression tries to find that best line of fit for the data available. Classification, so it will classify the available data to the corresponding labels. And for clustering is unsupervised. You don't have the output corresponding output value. So what you do is you just find out the similar data points and cluster them in groups. So if you need to cluster them in groups, you need to understand which data are similar, right? That means clustering technique wholly depends upon some similarity criterion that will be defined case-wise. Okay, so this is the overview of the machine learning portion that gets involved with data scientists. Okay, now last few sessions we have already dealt with some data sets. Please mute yourself. Take this. Who is this?
Ma'am, you are a host. You can mute to everyone.
How do I do that? Okay, here. Okay. So we did deal with a few data sets earlier, right? But the thing is, in the real world, in the real sense, the data are not that clean, right? We have seen some issues already, meaning a data set with some missing values. So in the real world, we will always have data set with missing values, data set with error entries in it, data set having irrelevant columns, and many different issues. Okay. Now, looking at these issues, you can understand why data scientists get paid that much, right? Even after you remove these issues, there is probability that you may not achieve the required efficiency. You may not achieve the required efficiency in your modeling. There always remains a probability. And in future or in current scenario also, machine learning is appearing right in the scene, and it is trying to automate most of the data intensive processes. Now, since data scientists deal with data and machine learning coming into the picture, trying to automate the data intensive processes, so data scientists are expected to be equipped with the in-depth knowledge of machine learning. Okay, so that is why I have dedicated this session to machine learning in data science. Fine. So now let us deal with this regression thing via a few lines of code. Okay. Python provides us with sklearn. You might be knowing, huh? We will use sklearn here, sklearn library. So as usual, you have to import the libraries first, right? The usual ones, pandas. Any question if crops up in your mind, you can put forward. Import NumPy, yes. Let us import.
What is the role of data analyst?
Okay, so data analysts are those people that appear before data scientists, you can say. If you need to understand,
it means that they do this pre-processing part is done by data analyst or data scientist.
Yes, data analyst. Actually, data analyst actually deals with data collection majorly, then data storage, and then data cleaning part overlaps with data analysis and analysts and data scientists. It overlaps between them.
Okay.
There are many terms that might confuse you. You have data engineers also. You have machine learning engineers as well. Pandas is PD, NumPy, and P. So I have imported these three libraries. Let's run it. So for today's case, let us work with some dummy set. Make things little clearer, right? So we'll use some random numbers. And P provides you this random. First, let us fix the seed to any value. Let us name our input and output data to be X and Y. Let X be this random value. Suppose this 100 data points, let us take for now. X is your input, okay? Meaning X will be your independent variable, right? This is the usual format, no? Y is your dependent variable. Suppose I define Y to be plus 3 times your X, and let us introduce a little randomness here. Okay. So we have defined X, we have defined Y using the random function. So this becomes your label data set. Is it? You have X, you have Y, right? Input output pairs. Let us plot it using the scatter plot. plt.scatter X comma Y. So this is your data. Huh? This is our generated dummy data set. And this is how they are scattered. Now, as you can see, this data set looks suitable for linear regression, right? Sorry. Linear regression. Now, what linear regression will do is it will try to find a line of best fit that will pass through these points. Yes. So for that, we need to call our linear regression, right? From the library. The library is scalar dot, it comes under the linear models. Model, import linear regression. After you import, you will create the object corresponding to that linear regression. Let me name it as suppose LR. LR is your linear regression object that we will use to fit your data into. Okay. Run this one also. So the object is created. Now you have to use this LR to fit into your data. How do you do that? You have this fit method. LR.fit, you have to fit into your X comma Y. Now after you fit the data, what is the ultimate objective is to get that line of best fit that will help you to predict the output for some inputs, right? So we will try to check here the predictive capability of your model. So what you will do is, suppose this name is Y print. Predict. Suppose we predict our X values only. We already know the corresponding Y value for X. We have prepared our linear regression model here. This linear regression has found one line of best fit for our data. Now using that line of best fit, we are trying to predict the Y values corresponding to whatever the X values we have. Okay. So Y-pred contains those predicted values. After the prediction portion is over, you need to check, right, how efficient your modeling has been. So what you will do is you will check certain metrics. So your sklearn provides you these metrics. We will look at the mathematics behind these as well. Was it squared? No, scores. R2 scores. Mean. Let us suppose look at these two. Just to have a feel of how the algorithm is working. So let us name this as MSC. So we need to check for Y and the predicted value of Y, right? This one. And R squared, let me name it as R2. R2 score, again between Y and its predicted value. Let us print those results. R squared. It is R squared, right? What happened? Oh. So whatever the model you have prepared, whatever the best line of best feed you could get, that line of best feed provided you with these predicted values. Okay, you already know what the actual values are. Using the algorithm, you have found the predicted values for the same. Now you have found the mean squared error and the R squared value. Okay. Now, if you look at these values, you will find that for the given data set, linear regression modeling is just working fine, right? Because the mean square value is in the order of 0.07. And the R squared, this R squared, for the time being, you can understand it to be that it represents the percentage of the Y value that is being explained. So how to tackle those improvisation part that we will cover. We will also have to look at what actually these MSC and R squared are. These are some, you can say, almost mandatory interview questions. They are usually asked R squared thing. Can you explain MSc and all? So in a simple sense, this is how you do linear regression. Okay. So linear regression will help you predict, right? Once you get the line of best fit here, this one. So for any point on X, you will be able to generate the corresponding value for Y, right? This is how it helps to predict the values. So this is your linear regression. So when we talk about linear regression, again, two things come into the picture. You will find two subdivisions of it. One, we call it simple linear regression, okay? And the other is multiple linear regression. When we say simple linear regression, means we have this dependent variable depending upon a single independent variable, okay? Now, since this is a line, right? So you can always frame this equation for it now. B0 plus B1x. Is it? You can actually print out these values. Do you see? The line of best fit that was found for this data set, that line of best fit has these B0 and B1 values, okay? This is the intercept. This gives you the intercept value for the line of best fit. Intercept value means what? That is your B0 value. This is B0. And simultaneously, it gives you the value for the coefficient of X as well. Coefficient of X means what? This is your slope, right? So actually, following these steps, you have found a straight line whose intercept is y intercept is this, and whose slope is this, okay? So this is what your simple linear regression does. You can always have multiple linear regression. When I say multilinear regression means we are talking about the case where we have dependent independent variables, meaning this one. Okay. Now what I will suggest is you try to generate a dummy data set that will mimic this condition of multiple linear regression and try to fit the linear regression model into it. Try to find, since you have more than one independent variable, instead of getting a line of best fit, you will get a plane of best fit, right? In this case. Here in case of simple linear regression, you got the line of best fit. In case of multiple linear regression, you will get a plane of best fit. Now that plane will be defined by these coefficients, this intercept along with these coefficients. Try to generate a dummy data set, try to fit in the model, try to find these coefficients. So let your this in the next session, we will try to understand the statistics related to this linear regression. Linear regression is considered to be one of the simplest machine learning algorithm. However, the statistics behind it might be daunting. So we will try to cover it tomorrow, in tomorrow's session. Okay. So let me wind up today's session here only. If you have any queries or questions, so you can put forward. Are the things clear up to this point?
Everyone, any doubt, any question, please ask this time.
If there is no doubt, though, okay, we can wrap up the session. Okay, sir, you can end the recording as well.
Okay. No question? Madam, can I stop this training session?